again. MPLS is quite big topic. That's why we need to have some repetition of same thing again and again so that it goes deep in your mind. So this is just router 1's configuration I have done. What I have done is I have enabled OSPF on these two interface only, the provider's interface. The reason why I need to run OSPF is I'm going to form VPN with the help of BGP. To be more clear, I'm going to form IBGP between R1, R3 and R4, and you know about IBGP. If you want to form a neighbor with a router which is far away, not directly connected, you need reachability. R1 should reach R4, only then you can form IBGP neighbor. That's why I need OSPF. R1 should reach R3, only then I can have TCP three-way handshake and form BGP 179 neighbor with R1 and R3. So I need OSPF. I need also BGP to have a VPN tunnel. So yes, it's recording. Started. We need definitely OSPF. On top of it, we are going to have BGP to form VPN. Now that's the reason why I have OSPF configured on these two interface, and the OSPF is not area 0, it is 100. I have a reason why I have 100 area. I want to show that if I have OSPF, let's say here on customer A, OSPF let's say 10, and I have customer A2, that is also OSPF. This customer A likes only OSPF on different remote office as well as the local office, so they run only OSPF. And here let's say the area number is 100. No, area number is 110, or it can be 100 also, never mind. Why? This interface is going to be in a different routing table, different OSPF process. So I want to show that the routes from area 110 can be given to area 10 without having area 0. OSPF always needs a backbone area to communicate between non-backbone areas. So this is a non-backbone area, area 110, and this is also a non-backbone area. This is also a non-backbone area. There is no backbone area at all, but still you will be seeing here these two non-backbone areas communicate without a backbone. The truth is there is no need for a backbone. Why? The routes that are advertised from CA2 will be redistributed into BGP. And then from BGP it is again redistributed to OSPF 10. So there is no need of area 0. So sometime in some book they confuse us by saying MPLS, cloud, act as a super backbone. Those are all okay to listen, okay to say, but what actually is, there is no need for a backbone because there is no OSPF, real OSPF in the middle between CA and CA2. Though there is a OSPF, your OSPF traffic from the customer to the other customer branch, it's not going as a OSPF route. It goes as a MPLS BGP route, MBBGP route. They are going as a VPN routes, not as OSPF routes. Only if it goes as a OSPF route, then there is a need for a backbone area. So what I am saying is just OSPF concept. But because you have MPLS in the middle, it doesn't act like area 0. No, that's wrong. But some people, to make us understand, they say it acts like a super backbone, it acts like a backbone. Backbone means it's always area 0 only. Here there is no need for area 0. So what I'm going to do is I'm going to just take OSPF only here and here, and between B1 and B2 I'm going to have a RIP here, and then I'm going to have BGP here. We are not going to see EIGRP today, we will see EIGRP tomorrow. So this is how we are going to do, and I'm starting with router 1. Now the reason why I don't use EIGRP today is I want to teach you EIGRP in a new iOS which is popular now, iOS version 15. In older exams, in older CCIE, it was only 12.4 version of EIGRP, the iOS version. Now we have EIGRP version 2, which runs on iOS version 15. So I want to just introduce you introduce you to the new EIGRP configuration and then take you to VRF configuration. So Aslam has already gone through the EIGRP, new EIGRP. I remember I was teaching to Aslam 2 months before, and he is aware of EIGRP, new EIGRP. But for the others, I would like to introduce before I take into BGP, MP BGP, before I use it as a customer routing table. So I'm not going to use EIGRP today. We have a lot of other things to understand. So R1 has got only OSPF, and this OSPF is not customer OSPF, it is provider's OSPF. It is in area 100. And serial interfaces are going to have this IP address. Though I give IP address now, when I take this interface from the global routing table and assign to a VRF, this IP address will be removed. Then again I need to put it back. Not a problem, we will do it. So let me paste this quickly. And every router has got a loopback interface. As I've said here, all the provider routers has got a loopback 0 interface with 10.n.n.n. Usually people type 10.x.x.x. My keyboard doesn't support x. So here n stands for the router number. If it is router 1, it is 10.1.1.1. If it is router 5, it is 10.5.5.5. The reason why I use loopback interfaces here, we got redundant path to reach the other routers. R1 can reach via R2, R3 and R4. It can also reach via R5. We have redundant paths. Whenever we have redundant paths in BGP, we will have a loopback interface as the source address. We will also say update source command. That's the reason why I have loopback interface here. Now if you have a loopback interface, MPLS also will pick the loopback interface as the router ID, same like OSPF. So OSPF router ID is also same here, MPLS router ID is also same here. Not only that, PIM neighbor address is also going to be the loopback interface address, because it is taken as the router ID by, not PIM, I'm sorry, LDP. So LDP is also going to pick the loopback interface address as the router ID. So we will be forming VPN also with the help of loopback interface of our neighbor. Let's go step by step. I'm not going to do any BGP kind of stuff. Simple basic IP address found in the simple IP address, and then OSPF on loopback interface and the ISP interface, the interface that connects to ISP routers. Now you must run OSPF on loopback interface. If you fail to do that, you cannot expect MPLS properly functioning. The reason why, MPLS picks the loopback interface address as the router ID, and with that only it will form neighbor with the adjacent routers. And for adjacent routers to send and receive the update, that particular address that is chosen as the router ID should be a reachable address. To provide reachability, we enable OSPF. So do not forget, we must enable the routing protocol, IGP protocol, on loopback interface when you enable MPLS. Alright, so I select all, I copy, I paste it on router 1. I made a mistake, not CV1. Right, it is. I should have pasted on router 1. Okay, here we go. Okay, there's a mistake, some sort of mistake I have done somewhere. Okay, here, not interface, it is IP address. IP address 17.0.0.1. Shall I copy now? Yeah. Pasting once again. I should have typed end, not en. So once we correct, and later we will use the same template for the other routers. I don't see any other error. It's perfect. Show IP interface brief. We got loopback interface and we got these IP address on place. 12.0.0.1 and fast Ethernet 0/0, 15.0.0.1 and 0/1. The other two interface IP address will be removed when I assign them to the VRF, so we need to put it back. So let it be there. Serial 1/0 17.1 and serial 1/1 16.1, and all interfaces are up. Happy, fine. One more verification. Show IP OSPF interface brief. I got 2 interfaces running, 3 interfaces including loopback running OSPF. Right. Next, let me finish our 4 and R3 because they got 3 interfaces. R4 and R3. So let me write it for R3 first. 10.3.3.3.3. Okay, and serial 1/0 will have 39.0.0.3, and then serial, there is no serial 1/1. Let me remove this. Fast Ethernet 0/0 will have 13.3, which will run OSPF. 15, there is no 1534 here. 34.0.0.3 serial. Okay, OSPF will run only on the serial interface. There is no OSPF. Okay, I'm copying this and pasting it on router 3. It is done. Similarly, on router 4 we got 4 interfaces including loopback, so this will be 10.4.4.4 and serial 1/1. I don't have 0 there, I have 1. Okay, now 38.4 fast Ethernet 00 will have 34.4 here, and fast Ethernet 01 will have 45.4. I copy all and I paste it on router 4. Okay, 4 routers are over. Now 3 routers are over. Now let's finish 2 and 5. Router 2 will have 10.2.2.2 and there is no serial interface. Let me remove this. And fast Ethernet 0/0 on router 2 has got 12 on it. Okay, and fast Ethernet 00 has got 12, 01 has got 13. Select all, copy, paste it on router 4. Oh, what am I doing? I should have pasted where? I should have pasted on router 2. I pasted on router 4. Oh my god. Very big mistake I did. Very, very bad. No problem. Interface loopback 0, IP address 10.4.4.4, 255.255.255.255, IP OSPF1 area 0, interface fast Ethernet 0/0, no shut, IP address. You cannot do like this when you have IPv6. The reason is single interface can have multiple IP address on IPv6. If you want to really if you want to put a new IP address, you need to remove the old IP address before you put the new IP address. Whereas in IPv4, you can simply type in the new IP address that will override the older one. Alright, so I don't think there is other changes needed to be done. Show IP OSPF interface brief. Okay. Show IP interface brief. I think everything is in place. Perfect. 2 is over 3, 4 is over 5. 10.5.5.5 has got 2 fast Ethernet, one has got 15 on it, and another one has got 45. We copy all, I paste it on router 5. So far we have done simple basic thing, nothing big new. Right, on CA router the configuration goes like this: interface loopback 0, IP address is 10.0.0.1, 255.0.0.0, interface serial 1/0, no shut, IP address is 17.0.0.1, 255.0.0.0. So here 17.1. So the gateway I'll give different address, maybe 17.10. Has anyone got dropped? So we got router 5 configuration on place. Did I paste it? Yes. Okay. R7, sorry, CA1 is also done, and the routing protocol that we are going to use is this: router OSPF. Let me enable on the interface IP OSPF1. I'm saying area 10, interface loopback 0, same. So if you check here, show IP OSPF interface brief, we got 2 interfaces running OSPF in area 0. Let us do on CA2. Interface serial 1/0, no shut, IP address is 16.0.0. Let me make it as 1, 255.0.0.0. So this is the IP address on here. So on the gateways it will be 10, 16.10 and 17.10. No need of notepad. Okay, I'm on RCAB. Now here we are going to enable RIP. So before that, loopback interface 0, IP address is 192.168.0.1, 255.0.0.0. So this is what the address we have here. Okay, now Enabling RIP, router RIP version 2, network 192.168.0.0, network 16.0.0.0. Yes? Oh my god, again I'm doing wrong. Okay, I'm sorry then. Interface serial 1/0 will have IP address not 16, I think I gave 16. IP address is 38.0.0.1, 255.0.0.0. Okay, I should arrange this proper. CA2 and B12. Okay, CB2. This is perfect. Okay. Okay. So now then I need to remove RIP. No router RIP. 192 is the same one, so no problem. I'll say router OSPF interface serial 1/0. Here itself I can do. No need to go to global configuration mode. IP OSPF 1 area 110. Interface loopback 0. Same. Let's verify show IP OSPF interface brief. Alright. So C2 is done. Next is did I do CB2? CB2? No. Let me finish CB2. Customer B2. Interface serial 1/0. No shed. IP address is 16.0.0.1. Interface loopback 0. IP address is 192.168.0.1. 255.0.255. Here what I'm doing is same IP address I'm giving on CB2 and CA2. 192.0.0.1. Likewise CA1 10.0.0.1 on the loopback. CB1 also will have the same IP address. I want to show that they won't conflict. When someone ping from CB2 the destination as 10.0.0.1, they will not be reaching CA1. Instead they will reach their own 10.0.0.1, which is taken care by route targets. So those things, I want to show. That's why I'm having the same subnet on the inside of both the customers. Next, the routing protocol that I want to have here is router RIP version 2, network 192.168.0.0, network 16.0.0.0. Alright, no auto summary. Anyway, we have not subnetted. That's not needed. I just did it. Did I remove RIP here? Yeah, it is done. So one more router to go. Enable config T hostname CB1. No shed. Sorry, interface serial 1/0. No shed. IP address 39.0.0.1. Here we are going to have BGP interface loopback 0. IP address is 10.0.0.1. 255.0.0.0. So let's enable BGP here. Router BGP autonomous system number is going to be, let's say, 10 here. So it is BGP 10. BGP 10. Neighbor is 39.0.0.10, which is going to be the address of this interface. 39.0.0.10. And then you know that I need to type remote AS as what? 125. The remote AS is 125. And the network that I would like to advertise is 10.0.0.0. It is not subnetted, so I'm not using mask command because it is not subnetted, the default mask on the loopback interface. Okay, BGP is running. So customers are ready. There is no more thing to do, on customer side. Only after MPLS is up, VPN is up, we will be checking the ping. We will check the connectivity from one remote site to local site, local to remote and remote to local, by pinging and by tracing the route. Now let's start MPLS. Simple MPLS. So far we have not done anything related to MPLS. This is the first step. MPLS IP interface range fast Ethernet 0/0, 1 no -1 MPLS IP. So if you want to check what all interface runs MPLS, the command is show MPLS LDP, show MPLS interfaces. It shows that these are the two interfaces that runs MPLS, and LDP is the protocol by default running on this, and it is operational. Right. See, the troubleshooting will become easier only when you know what we see on what show command. If you know what all I can get by typing show MPLS interface, then when I think about troubleshooting, if I want to check which interfaces are running MPLS, I'll directly come to this command and type in this command and check what runs MPLS and what not. Show commands are very important. More you use show commands, more you become a good troubleshooter. Now next is let's do on router 2 MPLS IP interface range fast Ethernet 00-1 MPLS IP. So similar command goes on the other three routers. MPLS IP interface range fast Ethernet 0/0-1 MPLS IP. R4 MPLS IP interface range fast Ethernet 0/0-1 MPLS IP. MPLS IP interface range fast Ethernet 0/0-1 MPLS IP. I see some sort of error. Let's check how many interface. Show IP OSPF interface brief. All run OSPF area 100. That's perfect. What about router 4? Show IP OSPF interface brief. That's why it was showing error for me. Why am I running 0? All should run area 100. I made a mistake. Interface loopback 0, IP OSPF 1 area 100. Interface fast Ethernet 0/1. I understood that I made this mistake when I was doing something else on R5. I was just doing something and I was seeing this one. The virtual link will not come. This type of error I should not get if all are in same area. Only when we have multiple areas and without area 0 in the middle, we will have this. It will say use virtual link. You don't have an area 0. Use virtual link. Connect to area 0. Here show IP OSPF interface brief. Okay, here it's perfect. Show IP OSPF interface brief. Perfect. Show IP OSPF interface brief. Alright, so it's very, very important that every log message you read, I just come to know that something wrong with the next router. As I was doing something on R5, I understood something wrong with fourth router. Why I didn't suspect first router? Because I'm seeing this message coming because of the fourth router, 45.0.0.4. So this is how we need to be alert. Now let's say trace 10.1.1.1 with the source of 10.4.4.4.4. I see the packets are going via router 5. It goes to router 5, and then router 5 takes out the label and sends to the final destination, which is router 1. Router 1 has got 10.1.1.1, the shortest path, because we have OSPF. The cost here on this link is 10 and here is 10. Sorry, the cost here is 1 and here is 1. 1 plus 1 is 2, because it is 100 Mbps wire. Whereas if it goes via router 3, the cost is 3. So OSPF has picked the low cost path, shortest path. Alright, so our next step is, we see labels are assigned. Now if I'll trace route from here to router 2, 10.2.2.2, I see the packet goes to router 3. From router 3 it goes to router 2. Let me do one more time. I see that router 4 has decided to go via router 3. The reason is same, low cost. 2 is the cost. If I ping 12, if I do trace route to 12 network, cost is equal. Let's see which one it picks. It picks any one of. See, in this time it goes via multiple paths because the cost is same. ICMP says I can go via router 3, I can also go via router 5. Though trace route may show you 2 paths, OSPF will pick only one path. I want to show you that. Show IP route 12.0.0.1. I'm asking the routing table. It says there is 2 paths via router 5 as well as via router 3, but which one is selected? Going via router 3 is selected. The metric on both the link is 3 and 3. It's same, but it picks this one, not the other one. OSPF will not do load balancing like EIGRP. Alright, next is MPLS is done. Let's check the table on R2. Let me go and check table on R2, the LFEB table. Show MPLS forwarding table. This is the routing table of MPLS. Show MPLS forwarding table. It has got labels. See, it has got 2 labels for 45, because 45 on R2, 45 can be reached via router 3, can also be reached via router 1. Why? The cost is same. If it goes like this, 1 plus 1, 2. If it goes like this, say 1 plus 1, 2. Because the cost is same, it has got 2 paths. And see the label. It's the same label. This is what called as forwarding equivalence class. FEC, forwarding equivalence class. This is equal, this is same. Because it is same, it is given only one label. Local label is only 16 for 45. So anything comes with 16, it will send via this or this, according to what the Ceph table says. Let's take the Ceph table. Show IP Ceph for 45.0.0.5. Okay, it has got two roots with label number 22 in it. Next, MPLS is done. Let's go to the next level. Before forming VRF, I think I should form VPN. Yes. Same destination, two paths and same metric. Condition is they're equal paths, they're equal metric paths. Yeah, because you got show IP route, you see routing table says I can go via two routes. There are two routes. Whatever routing table has, it has to provide the label. Routing table has got two routes to reach 45, so it has to provide label, but these two routes are for whom? Not for two different network. It is of equal class, same type. That's what equal class means. So it provides only one label. Sorry. So is there any understanding problem? I can explain again. Yes. You know, see, no, you're confused. See, I'm talking about the local label. I'm not talking about the neighbor label. Locally, I have only two labels, or only one label. Local label, I'm not talking about outgoing label. I'm not talking about this 22. This 22 is coming from router 1. This 22 is coming from router 3. If I clear MPLS, then this label will be different. I'm not talking about this. I'm talking about my label, local label. See, if I'll have R11 connected to R2, what R2 is going to advertise for 45 network? 16 only. Not 2 times 16. It's only 1 times 16. Because it is forwarding equivalence class. Equal, same. Yes, system wide, absolutely. If you change it as interface wide, then it will have separate label for each 45, because it is learned in different interface. But interface wide is not for us. It is old technology when we have ATM. So no need to worry about those. It is there in my PowerPoint presentation. So do not worry about those stuff. We don't have any transport over MPLS. ATOM. We don't have ATM now. Need not to worry about that. We are dealing with system wide. Alright, so what is next? We have done basic verification, MPLS verification in the previous classes. We are not going to do now. We will get into VPN. Before we get into VRF, let us finish VPN today. Yesterday we did VRF first and then VPN next. Let's do this time VPN first. Then we'll get into VRF. I'm going to form VPN now. Between whom and whom? R1 is going to form VPN between 3 and 4. Similarly, R3 will form VPN with 3 and R3 will form with R4 and R1. So I'm going to R1, I'm going to form two neighbors. router BGP 125. First, normal IBGP. If you can write down parallelly, you write down the steps. BGP, normal BGP. After enabling MPLS, we have not done anything other than sorry. So neighbor, we are going to form first IBGP between R1, R3 and R4. Neighbor 10.4.4.4. Why I'm using this? Because we got redundant paths. Remote AS, same 125. And we got another neighbor 3.3.3.3. Because I use the loopback interface of my neighbor, I need to source it with my loopback, because my neighbor also will point towards my loopback. So let me source to these two neighbor with my all BGP packets should be sourced with my loopback 0 interface, which is 10.1.1.1. Similar story for the other guy. This is basic BGP configuration, nothing new. Let me do it on R3 also. Router BGP 125, neighbor 10.1.1.1, remote autonomous system is 125. One more neighbor, the very next neighbor 10.3.3.3, remote autonomous system 125. Come on, sorry, 4.4. I'm already in 3. Okay. So router 3 is also ready to form neighbor. Router BGP 125. Okay. So I should see two neighbors. A kind of fully mesh we have done. Fully mesh. But we don't run BGP on R2 and R5. And so only when you run on R2 and R5, then you can call it as fully mesh. This is not really fully mesh. Okay. So we got VPN. Yes. Yeah. I didn't hear you proper. Oh, thank you. But you know how it formed neighbor? I see this is forming neighbor. Neighbor is up. You know how it is? It is actually one-way neighbor, not two-way. Because it is TCP and the addresses are reachable, they can form neighbor. If one is sending the TCP request, the other is ready to respond. Because I did update source command on R1, this neighbor is happening. But it is not forming neighbor with R3. Why? There is no update source command given on R3 as well as R4. So there is no TCP session success. Even if you didn't understand what I said now, no problem. Leave it. You see, this is going to form neighbor between R3 and R4 now. Though I have not said update source on R3, it is forming neighbor. It is because of TCP. I think I missed one more neighbor. Only for 3 I said. I also need to say for 1. Alright, now R3 router BGP 125 neighbor 10.4.4.4 update source, sorry, yep, correct, loopback 0 and okay. Done. So normal BGP is what so far enabled. Via VPN is nothing. See how easy it is. Go again back to our BGP and say address family. This address family we will be using for VPN as well as VRF. This command address family is both for VPN as well as VRF. So no confusion here. Now I'm not dealing anything related to VRF. We are doing VPN. So to do VPN, what is the first command? Address family. Before you form VPN, make sure you have already neighbor and then VPN. So I am now VPN. Address family VPN v4. Why? There is also v6. You can also do VPN for version 6 IPv6. We are doing IPv4 now. Address family VPN v4 unicast. So now you have just said I want to form VPN, but with whom? That you should say. With neighbor. You may have many neighbors, and you may not be happy to form VPN with all the neighbor. You may need to form neighbor with 1 or 2. So that neighbor you need to activate here. You may have 100 other neighbor, normal simple BGP neighbors, but 1 or 2 you want to form this VPN. That 1 or 2 you have to mention here under this address family. Address family VPN v for unicast neighbor 10.1.1.1 activate. Activate is the command. Next is neighbor 10.3.3.3 activate. I'm sorry, I'm on R3 4.4.4.4. Okay. Don't worry about this. Notification neighbor 10.1.1 unicast topology base removed from the session. Only one side we have done. It will come up. Now next is, let us go to router 1 now. Same command. Router BGP 125 address family VPN v4 unicast neighbor is 10.4.4.4 activate. Neighbor is 10.3.3.3 activate. Next is, let us go to, see the BGP is coming up now. It went down and come up because both the way there is VPN got activated. Now let us do one more router, which is R4. Router BGP 125 address family VPN v4 unicast and then neighbor 10.3.3.3 activate. Neighbor 10.1.1.1 activate. Now VPN is up. That's all. One single command. Neighbor so and so activate. Where? Under the address family VPN v4 unicast. VPN is only this much. MPLS VPN. People say too much about MPLS VPN. It's only this much. The other parts are VRF and redistribution. Taking from customer routing protocol, giving into BGP VPN, and then taking from BGP VPN, which is called MPBGP, and giving to customer routing table, customer routing protocol, which is redistribution. VRF and then redistribution between routing protocol. That's all is left. Okay. Now how to verify VPN? Show BGP VPN v4 unicast all summary. It shows that there are two VPN neighbors. One is router 1 and router 3. If you cut the summary out, then you will get to the networks that are in the tunnel. So far there is no network advertised, no network kept inside the VPN tunnel, but VPN is up. If I go to router 1 and check the same command, what's the command? Show BGP VPN v4 unicast all all summary. I see 3 and 4 as neighbor. Alright. Let's check one more time. Show MPLS LDP interfaces. Show MPLS interfaces. Okay. Alright. MPLS is also there. BGP is also. VPN is also there. What is next? VRF. So we are getting into the final section. I can say this as final section. You see, IPVRF CA can be any name. Route distinguisher. What is the use of route distinguisher? This is a 64-bit value which gets added to the customer's route and these customer routes are kept inside the VPN tunnel. So when they are inside the VPN tunnel, they are not going to get mixed with the other customer routes, even if both the customer have same subnet. How they are not going to get mixed? Because they got two different RD value prepended to their updates. So when CA1 advertises 10.0.0.1, in the VPN it will be seen as whatever I type here, 1:1 10.0.0.1. This 1:1 is a 64-bit value, gets added before the subnet that is advertised. When that same 10.0.0.0 advertised from CB1, in the VPN it will be seen as 2:2, because that is going to be the route distinguisher on VRF CB. 2:2 10.0.0.0. So 2:2 10.0.0.0 is different from 1:1 10.0.0.0. So route distinguisher is given, which is locally significant number. I cannot use the same route distinguisher number for CB in the same router. Next is route target. Route targets are the one helps to identify the target to which the update has to be delivered. That's why it is called as route target. So we use the import and export number, which we learned in the previous class. I don't want to use different number for import and export. I want to use the same number, so I need not to mention import and export. I'll simply say what, 1:1. This route target is also a 64-bit number, 32:32 number. It can be anything. It can be a customer IP address or the destination to where it has to be. It can be anything. Route distinguisher number and the route target number need not match. I am simply matching to keep things simple. You can have different. Now when I say route target 1:1, router understands that route target import 1:1, route target export 1:1 without me mentioning separately. And then one more VRF let me create. Before that, let us verify. Show run section IP VRF. So I am seeing only the VRF related output here. So it's the same configuration that should go with router 3 and 4. So what I'll do, quickly I'll paste it and come. Router 4 pasted. Router 5, see, I didn't say export and import. As I told you, if you don't say, it will automatically take for import and export the same value. I'll paste it on router 3 now. Okay. So next is, let us do for our customer B, IPVRF CB, route distinguisher I would like to give 2:2. Route target I want to give 2:2. Let's verify. Show run begins with IP VRF. Okay, this is for customer B. Let me paste this one also on the other two router. All right. So VRF is only this much. What is next? Assign the interface to VRF. I would like to assign serial 1/0 to VRFCA and serial 1/1 to VRFCB. Before I assign, I want to show you. Show IP interface brief. I see that there is some IP address. Okay, let me show on R1. Show IP interface brief. I see there is some IP address on serial. But see what happens when I assign to VRF. Interface serial 1/0 IPVRF forwarding for CA. See, it says the interface IPv4 disabled, address removed due to disabling VRF CA. Because it has become member of CA, previously it was a member of global routing table, the IP address is removed. Likewise, I'll also go to serial 1/1 and assign it to CB. Now I want to show you the address is removed. Show IP interface brief. You see there is no more address on serial interface. So we need to be careful here. If you have already assigned IP address, that gets removed. So we cannot assume that it's still there and keep going. Let's go to interface serial 1/0 and assign 17.0.0.10 because the other side I have given 17.0.0.1. Interface serial 1/1 IP address is 16.0.0.10 255.0.0.0. Okay, it is done. R3. Interface serial 1/0 IPVRF forwarding for CB. Is it CB? Yes, CB. Now I have only CB customer connected to R3, but I have created two VRF CA also. Why did I do that? There is no meaning in doing it actually. You need not to do that. I should have not copied and pasted the C A VRF on R3. But nothing wrong if it is there. It's not really needed. If you want to delete, you can delete it. But nothing wrong in keeping it. Maybe later I may have another branch office opened by this customer in this location where R3 is. Alright. So let us put the IP address on this interface 39.0.0.10 255.0.0.0. Alright. One more router. Router BGP, sorry. Interface serial 1/1. IP VRF forwarding CA. IP address will be 38.0.0.4 sorry 10 255.0.0.0. Now if you see on this router R1, I'll see 3 routing table, one for the global which is for ISP, the other 2 for 2 other customers CA and CB. Let's verify that. Show IP route CA VRF CA. I see the routing table of CA, and these are the routes. And when I type CB, I see the routing table of CB. And when I simply type, I see only the normal routing table, not all the routing table, only the default routing table. You do not see any serial interface here. This is default. When you simply type show IP route, it's a default routing table. When you type show IP route VRF all, star means all, then you see what? First the global routing table, followed by the CA routing table, followed by the CB routing table. So this is the command, VRF all command. Star means all. If you want to see specific table, as we already saw, it should be like this, CB, only the CB table. Alright, so we have, so far what we have done is we have enabled VRF, we have put the interfaces on VRF. I will also show you those verification commands. Show IP VRF detail. You can see here that there are 2 VRF. One is VRF CA. Because I created this one first, it has got ID number 1. And because I created this one next, I got ID number 2. No other reason. Some people ask in interview even these things. What does VRF ID2 means? How the 2 come? These are all unnecessary questions, but what to do? Some asks we have to answer. This is what created next. After this was created first, so it has got ID 1. And this is route distinguisher that we gave and route target we gave. And these route targets are exported into the VPN and imported into the VPN as BGP extended community values. And we see the interface that is assigned to this VRF. We can have more than one interface assigned to this VRF. Here we have only one customer in CA. If you have multiple customer in CA, you can have it. Right. What is next? So far what we saw is OSPF on the core, and then IBGP, and then VPN v4, and then the VRFs are created and interfaces are assigned to the VRF. Right. So the routing protocol on customer A1 is OSPF, I think, which is already running. Now what I need is I need to enable OSPF aware, VRF aware OSPF on R1. How to do that? Router OSPF. Do not give the same process ID which is already running. See, what is the purpose of process ID? To differentiate from one process to another process. To differentiate one OSPF and the other OSPF. I'm going to run another OSPF now. So I need to give different number. One is already OSPF, one process is already working for ISP. I want a separate instant of OSPF, so I need to say 2 or some other number other than 1, followed by VRF CA. So this OSPF instant 2 is running for VRF CA. If I'll have again OSPF for CB2, then I'll say VRF CB and process ID will be 3. So we need to have different process ID. Okay, now router OSPF2 VRFA, which network? Network 17.0.0.0, 0.255.255.255, area, what area? Area number 10. Area number 10. Let me check on CA. What did I give? Yeah, we have given area number 10. That's why it can form neighbor. Look at this. It has formed a neighbor. Now if I go to router 1 and check the routing table, show IP route for VRF CA, I am seeing this route coming from CA1. Okay. Now let's do for RIP. Router 1, router RIP. Here we use address family command. Address family. In BGP also we do address family. In RIP also we do address family. Tomorrow in EIGRP also we will see address family under the routing protocol. Only on OSPF we don't do any address family. We don't give any address family. We just give VRF right next to the process ID. But for the other protocols we need to use address family command. Address family, not VPN v4 and all. We are not doing VPN here. This is for VRF. Address family, address family IPv4 VRF. This is for customer B. Now after going inside the VRF, what we do? We advertise the network. We run RIP on 16 network. Okay. So RIP and OSPF is running with VRF awareness or under the VRF. For VRF, not under the VRF. For VRF. OSPF is running, OSPF process ID 2 is running for VRF CA. RIP runs for CB. Let's check the routing table. Show IP route VRF CB. Look at this. We are learning this from CB2 customer site. Now 2 more routers. On R3 I'm going to have EBGP relationship between these two. An R3 router BGP 125. My neighbor is 39.0.0.1. Remote autonomous system is 10. Why am I not using loopback interface here? Because I don't have multiple redundant paths to reach the customer. In case if you have redundant path, you know what to do. We'll use loopback interface. We'll make sure the loopback interfaces are reachable. We'll say update source. We will also say EBGP multi-hop command or TTL security command. Hope you three remember these things. You know, I was teaching this in BGP. Alright, so BGP neighbor 39.0.0.1 remote AS10 is given. But I'm not seeing BGP yet. Why, you know? That's a mistake I did. What mistake I did? Address family. See, this neighbor is not on the global routing table. He is inside VRF. This interface that connects to the neighbor, BGP neighbor, is inside VRF CB. So I need to say address family IPv4 VRF CB. I told you the address family command will be used for every routing protocol other than OSPF. So under BGP address family, we are not only using for VPN, we also use for VRF. And here I need to say the neighbor command. Right. Now we got, look at this, how nicely it shows. I got a neighbor called 31.0.0.1 for VRF, who is a member of a VPN, who is a member of VRF CB. And because it's a BGP, already VPN is there. The routes that are learned from the customer CB1 will be placed automatically into the VPN because they got EBGP relationship. Now for your surprise, you can see here on router 1, previously I was not seeing 10 network here. But now CB1 has given 10 network to R3. I want to show you that first before we go. Show IP route VRF customer B. I see that 10 is learned. 10 network is learned from CB1. This is CB1. And that is automatically placed into VPN. We no need to take from this BGP to this BGP and give it to the inside BGP. You no need to do that because they have EBGP relationship. It is automatically placed into the VPN because it is kept into the VPN. I see it in the other PE on the other side. All right. This BGP has given to R3. R3 has taken it and put it into VPN. So I can see on R1. Let's go and check on R4. Show IP route VRF CB. Show IP route VRF CB. I see 10 network. You see, can you really see what's going on here? I don't have customer B at all in this R4 router. But why I'm seeing this here? Because VPN, R4 is also having VPN on it. No interface you see in the routing table. Have you ever seen any routing table like this? No interface. You see here. It shows that 10 I can go via 10.3.3.3. I learned this through an IBGP neighbor. Because of that, my administrative distance is 200. No interface because it's VPN. Now, What's next? This OSPF R4. On R4, router OSPF 2, because one is already running for ISP. I'm saying 2. VRF CA network 38.0.0.0 0.255.255.255 area 110. Now I should see neighbor. Yeah, I got neighbor through the process ID number 2. So if I check the routing table, show IP route VRF CA, I am seeing 192.168.0.1 coming from my CA2, but I am not seeing 10.0.0.1 coming from the other CA. Why? Because the route is not kept inside the tunnel. R1 learns about CA. R1 learns about 10 under CA, but R4 is not seeing it. The reason is tunnel is made of BGP. Customers are talking different language. OSPF this side 10, this side OSPF 110. So this OSPF route has to be redistributed into BGP. Only then the others can see. Now what I'm going to do is I'm going to go here on R4. Here I need your concentration and attention here. It's very easy, but because I'm going to do redistribution again, then you will be going mad. What is he doing? Too many times redistribution. Did I left somewhere anything? So you are not going to lose. You are not going to really get confused if you concentrate. That's what I'll say. See, what I'm saying is router BGP 125, and I'm going to address family IPv4, not VPN-v4. IPv4 VRF CA. Sorry, CA. I'm saying redistribute OSPF process ID 2 for VRF CA. What I'm saying is this network that you are learning from CA2, put it into BGP VRF table. Already VPN is there, so this VRF can place it into the VPN. Why I'm not going under VPN v4 and placing it? Why I'm placing it on IPv4 VRF? You know, route distinguishers are there inside VRF only. For all the routes that is coming from customer A, route distinguisher 1:1 should be prepended. Only when you do this it will happen. Now you're going to see what, you know. Previously when I was typing, I was not seeing 192.168, but this time I see 192.168 I'm seeing, 38 I'm seeing. Means through VPN it has come all the way down here. You want to check the VPN? I'll show you. Show VPN v4 BGP. So sorry, show BGP VPN v4 for VRF unicast for VRF CA. See, on VPN CA, what has been prepended? 1:1 for these two routes. These two routes are coming from 10.4.4.4. Now how to go to 10.4.4.4? Here comes MPLS. Show IP or show IP Ceph for 10.4.4.4. It says label number 19. Look at this, how everything is bundled together. Now the packets inside the core are going to move from here to R5 See, this is R5's address. Actually, where I'm going to 38. These routers have no idea where is 38, but they know how to go to 10.4.4.4. So they take the packet and deliver to this guy, and this guy knows how to deliver it because he has got the routing table for customer A2 CA. He delivers. Now next is what, let me show you the overall VPN. This is only VRF VPN. If you simply say unicast all, you see one is VRF CA, this is VRF CB. Both are differentiated with route distinguisher. Alright, so next is what I have just taken this OSPF and put it into BGP. That's why I'm seeing here. Likewise, I need to take this OSPF and put it into BGP so that I can see it on R4. On R4, when I type show IP route for VRFCA, I am not seeing 10. Why? 10 and 17 is missing. Why? Because on R1, I didn't say this, router BGP 125, address family IPv4 for VRF CA, redistribute OSPF process ID 10, which is in VRF CA. You should be very careful. I'm sorry, not OSPF process ID is 2. We should be very careful in saying this. If we don't say this, we don't have OSPF 2 globally, nothing will be redistributed. We need to say, see this OSPF whose process ID 2 and which is also a member of VRFCA, that route, take it and give it to BGP. Now because I said this, when I go to R4 now and check the routing table, I am seeing 10 and 17. Now if you check the VPN here, show IP BGP, VPN v4, unique VPN v4 for VRF, all VRF, okay, CA, I'm seeing 10 and 17 coming from router 10. MPLS knows how to take you there. It takes you with the help of labels. Alright, now what is next? Similarly, on R4, not on R4, on R3, I am seeing only 10 that is coming from the adjacent CB1. I am not seeing 192. Why? From RIP we have not given to BGP. So what we'll do, we will say address family CB. I'm now inside the address family CB. I'm going to say redistribute BGP, sorry, redistribute RIP. Redistribute RIP. Nothing more needed. Just redistribute RIP. There is no need of VRF and all. There is no command VRF and just redistribute RIP. That's enough. Only in OSPF you say VRF. So redistribute RIP. When I say this, I will be receiving on R3, which one? 16 and 192. Look at this. 16 and 192. Now on R1, show IP route VRF CB. What I am not seeing is, now I am seeing 10. But what I am not seeing is 39. Why? We didn't advertise 39. BGP only when you advertise network by using network command it will be advertised. Not a problem. I am not going to advertise. If you ping from CB1 it won't ping. But if you ping with the source of 10, then it can ping CB2, because R1 knows only about 10, it don't know about 39. That's not a problem. If you want to see 39, what you need to do is go and advertise on CB1 like this. Router BGP what? 10. Network 39.0.0.0. See? Now if you go and check on R1, I see 39 also, which was not there just half a second ago. Alright, now all the customer routes are inside VPN and they are distributed to the other edge routers, PE routers, provider edge routers. But what is the use? Only provider edge router knows it. You see, on CA1 show IP route, I am not seeing 192 coming from CA2, but R1 knows it. R1 knows it. It says I am learning it from router 4, but it is not giving to CA1. Why it is not giving? Why it is not giving? We have not made it to give. See, it is there in VPN. We have to take it from VPN and give it to whom? OSPF 10. Now we did only one-way redistribution, means customer route to provider. But from provider we need to take it back, no? Not take it back. From provider also we need to take the update coming from the remote. So what I do again, I go to R1. This time I'll go to router, OSPF, process ID, VRF, CA, redistribute BGP 125, and then metric for OSPF. It will pick the default metric. No need to worry. I hit enter. Oh, this is OSPF. One very important is we need to say subnets. We need to say the command subnets. Why? By default OSPF will not redistribute the subnetted information. Anyway, we don't have any subnetted information, but still, I'm saying it to be on safer side. Now if I go to CA1, previously I was not having 192 and 38, that is coming from the remote site, but now we have it 38, 192. So CA2 route is learnt on CA1. Likewise, if you want to have CA1's route on CA2, what need to be done is, here we need to take from BGP, give it to OSPF. So I'm going to R4 and saying router OSPF2 VRFCA, redistribute BGP 125 subnets. Now when I say this, I can see CA2 having those routes, but the beauty here is they are shown as other area routes. It is not showing it as external. It is not showing it as E1 or E2. That is the reason why people write like this. What? This area 100, though it is area 100, it is acting like area 0 for you. Backbone area. In OSPF, it is not possible for us to have any other area other than 0 as a backbone. But when you have MPLS, it is possible. That's why they call this cloud or the MPLS cloud or the MPBGP as super backbone. It is not showing it as redistributed route. It is not showing it as external E1 or E2. If you know OSPF, you know this. If any routes are learned in OSPF, if any routes coming from A as BR, they will be shown as E1. By default, it is E2 without adding pathcast. If pathcast gets added, it is E1. You don't see that E1, E2 here. It has learned as a other area in the same autonomous system routes. Now, if I ping from here CA2 to 10.0.0.1, I am able to ping very clean, neat. See, this R4 knows about the other 10. Show IP route VRF CB. It knows about 10 which is on R3, but it is not taking to R3. It takes me to R1. What is the proof? What is the proof that I am pinging R1? I'll trace route. Trace route 10.0.0.1. You see here, two labels are there. Two labels. One for identifying the tunnel, the other for local motion. So from here only one hop. R5 is given label number 16 to this guy. You want to see that? I'll show you. Show IP VRF forwarding. Sorry, show MPLS forwarding for 10.1.1.1. It shows label number outgoing and local is 16. That's what I see here. The top label is 16. The MPLS label is 23. That has been marked before putting into the VPN. That is to identify the final destination, the VPN tunnel endpoint 17.0.0.10, which is this router. So here PHP doesn't happen. This bottom of a stack label, the bottom label, gets removed only after reaching the final destination. But this 16 is removed before sending it out from R5. R5 is the shortest path to reach R1. I showed you in the beginning. Multi-stack. This is called multi-stack. Alright. Now if I capture a packet between R5 and R6, sorry, R5 and R4, you can see it more clearly. Now what I'm going to do is I'm going to do the same ping once again. One more time. Let me ping from CA2. Ping. I don't want to trace route. I want to ping. You're going to see the same 16 and 23. Ping 10.0.0.1. Yes. Here goes the ICMP packet. I pick one. Okay. See, 16 and 23. The top label is 16, the bottom label is 23. There is no experimental bit turned on. There is 3-bit reservation for QoS or traffic engineering. We have not done anything about that, so it is 0. This top label is not the bottom label. It's a top label. That's why it is 0, meaning there is another label also. Only the bottom label will have bottom of a stack turned on. How many bits reserved for bottom of a stack marking? Only 1. Time to leave TTL, 8 bits reservation. 2 headers. Stack. Alright, let me stop this. It will take too much of my memory. Next is, let us also try pinging from C1 and CB1 and CB2. For that, let us go and check the status, current status. Am I seeing on CB2 The route 10, no. 10 is coming all the way from CB1 down to R1. I saw that, we saw that before. You see, show IP route VRF CB. We see 10 comes from CB1, but it is not given inside RIP. So what I need to do is, I need to say router RIP redistribute BGP 125. Very important is metric. In BGP you need not to say metric. In OSPF you need not to say metric. But when you do under RIP, you must say hop count. I'm saying just 5 hops. Simply, it need not be exact number of hops. 1, 2, 3 hops. Need not be that. Any hop. Yes. Very good. Thank you. Aslam, you are not sleeping. I am sleeping. Okay. So, address family IPv4 VRF CB. Give it. Good. Now if I go to CB2, I will see 10 network. It is. And also I see 39. Likewise, when you go to R1 and check the routing table once again for CB, I see 192 coming from CB2, and it is not given to R3. You see, R3 show IP route CB3. I am not seeing. Oh, I already redistributed. Okay, we already redistributed. Yeah, remember we took from RIP and we give to BGP. Yeah. Now this 192 is there on R3, but it is not given to whom, you know, CB1. Oh, sorry. I forgot that I have BGP here. Automatic eBGP updates will go and come. There is no need of redistribution. That's why I got here. Now you see, I'm going to do a trace route here. Trace 10.0.0.1. See, this goes to where, you know, this goes to CB2. What's this? It will go to CB2. It won't go to CA1. Why? Because I'm pinging from CB1. Okay, it goes to 10.0.0.1. Who is 10.0.0? No, we got 10.0. Sorry. I'm pinging my own address. That's the problem. I need to ping what, you know, 192 or 16, correct? 192.168.0.1. You see, now the packet will go to router 3, and from router 3 it will go to router 2 and 1, and you will have a lot of MPLS labels in the path, and then at last it will not go to CA2. Instead, it will go to CB2. Okay. Now it goes to the gateway. This is the gateway, router 3's address, and from there it will pick 2 labels, one for VPN, and the top. Look at this, 2 labels, 19 and 26, and now it has removed the top label and it has sent to R1. Why? Because it is PHP for the top label, and with the label number 26 alone it went to 16.10, this one, which is VRFB's interface, and then from there it is delivered to 16.1. So we clearly see that though the customers are having same network, they are not going to overlap, they are not going to merge because of route distinguisher. Alright, now we are able to ping from one corner to the other corner. Ping 192.168.0.1 with the source of my loopback. To that loopback the ping happens. Similarly, if I go to CA2 and ping the same address, sorry, CA1 and ping the same address, I will be able to ping, but this time I'm not pinging the same destination. Though the address may be same, but my destination is CA2. That you can see when you trace. When you trace, I should see 38.1 as my final gateway, final destination. When I trace here, it's not going to be the, come on, where am I? CB2, not CB2. I'm tracing route what 192. Okay, when I go to CB1, same network. When I trace route, my final destination gateway will be 16. So this is what the core MPLS. You know, if you know this, your CCI MPLS is done. What all we are going to learn tomorrow and day after tomorrow on MPLS, they are all advanced, real world, good to know. And what you see up to here is what actual CCIE MPLS. So we have taken around 2 hours. But in exam, this type of scenario will be there, and someone already enabled MPLS, you need to troubleshoot. Ping will not happen, or trace will not happen like this. They will expect you to trace or ping like this. They will show you the output. We need to have this type of output. Or ping should happen between CB1 and CB2. That's how the question will be. Ping is not happening, troubleshoot. Now you need to go and see all these BGP commands on the R1, R3, R4. First of all, you need to check with the MPLS, check whether Ceph is there on all route. There are too many things. But the troubleshooting time, the overall time is only 2 hours. And you have a minimum of 8 to 9 tickets out of 11 to be cleared. Only then you pass that section. Out of 9 tickets, 1 ticket is MPLS, only one. So if you are not finishing this in less than 15 minutes, troubleshooting, it's not that easy. So in exam, mostly people, what they will do, they will just skip MPLS question, they will do all the remaining troubleshooting proper. But MPLS is not that difficult if you understand. If you do the same topology through it thrice, you will be able to troubleshoot very easily. You will know what to check by typing what command, where to check, all the stuff. So we'll stop here today, and tomorrow we are going to continue with the same topology, few more services added to this.